Yeah. Good afternoon, everyone. Welcome to this Gen AI Full Stack Development Workshop. Yeah, uh, so we'll dive right in. So a few things. So this will be a hands-on workshop. So I hope you all have the prerequisites ready. That is an active OpenAI account, an AWS account, the AWS CLI configured on your local machine, and Python and all set up in your local machine. I hope that's done. Because this will require you to have all of those things. So yeah, so let me just share my screen here. And
So it will be nice if the audience, code along with Bhavesh, because it's a hands-on workshop and it's specifically targeted for hackathon, so that the teams become expert at hands-on AI development and deployment. So it will be nice if you can code along and follow the instructions and actually do it, in person right now.
yeah, okay, so let's get started here. So this is a workshop where we will be building a small LLM application, a simple LLM application, but still covering enough concepts that would help you to start on for a hackathon ideas. So this is, we like call it paper chat or chat with a document. A simple, straightforward, I think, is that we would have a PDF file and we would build a chatbot so that we can chat with that PDF file. In this particular case, it's going to be archive research papers. So let's say you have a research paper and you don't have time to read all of the 20 pages, or maybe you are a beginner and you don't directly understand directly reading it. So you want some assistance with reading a research paper. So what we'll be doing is we'll be creating a chatbot for that, where you can, let's say, upload a PDF file, specifically an archive research paper, and then just start talking with it, and it will fetch answers from the archive research paper to give you accurate answers. So this is what we'll be building today, and we will not just develop it, but we'll also deploy it. So we'll use AWS, we'll use a few things like OpenAI, of course, for the API. The GPT 3.5 we'll use, or you can use GPT-4, doesn't matter, it's just changing the model name. But yeah, we'll use any one of the GPT models, and we will use a vector database. Specifically in today's workshop, we'll use Upstash Vector database. It's a serverless cloud service, so that you don't have to host your stuff, host your own vector DB server. So, and it's also free and pay as you go. So yeah, so and for the front end, we won't focus too much on the front end today, but we'll just have a simple Gradio application for this. You use OpenAI, so there's a question that says, do you use OpenAI for building? Yes, you would need a OpenAI API key for today's workshop. Um, so I hope you all have that set up. If not, it doesn't take that much long to set up an OpenAI account. You just have to sign up on the OpenAI website and you can create an account. But apart from that, and more importantly, you would need an AWS account if you like to code along and follow along on this in this workshop. So before we start, we'll just talk a bit about what RAG is. So this is going to be hands-on, so I don't have many PPT slides or anything. So it's all going to be practical and direct to the code. So, but we'll just have a few mind maps and all. We'll create a few mind maps as we go along so that it's easier to visualize and all understand all the concepts. Uh, sorry there. Just give me a second. Yeah, yeah, sorry. Yeah, so we'll start with RAG, like what RAG is. So, but before I start that, one second. Uh, Actually, Vivek, can I rejoin using my cell start so that I can create Q&As and polls on Meet?
Yes, absolutely.
Sure. Just give me 1 second. I'll just rejoin it. Okay. So, firstly, Yeah, how many of you here are new to Gen AI or completely new to Gen AI? Okay, only hosts can create questions. Okay, never mind. Okay, just you can write it in the chat or give a hands raise if you already are familiar with Gen AI or have worked with OpenAI API, if not like not Gen AI in the traditional sense, but more like have worked around with the API or anything like that, just so I get an idea of the um, um, did I- okay. So there's one person who has worked on it. Anyone else? So I'm assuming then all of you are complete beginners in the space. Like, knowing know about Gen AI, have used summarization, nothing major. Cool. Okay, so assuming it's a mix of mostly beginners with a bit of people here and there who has a little bit of idea. So Gen AI is just a umbrella term for generative artificial intelligence. So anything related to Chat GPT or your stable diffusion, DALI, your image generators, and even the music generators like Suno AI or anything like that, all of those kind of come under Gen AI. So just to give a brief overview.
Your screen is freezed.
Yeah, it's not freeze. I mean, it's I haven't shared anything specifically yet, so I was just talking. I'll be sharing now in a second. Yeah. Yeah, so we'll just talk about what Gen AI is. So Gen AI is anything around is a subset of AI which deals with generating new content. So you're not just classifying, taking some data or manipulating it, but more like you are generating new stuff from it. So things like an audio, video, images, a code, anything. So the idea of Gen AI is to mimic human intelligence, like not really, I wouldn't say become like humans, but more like mimic how humans write. So anything any output that you see is basically a replication of how humans would do it. So their style and everything. So any biases that come along will all be dependent on the data you train it on. So major types of Gen AI that we have are like text generation. So the usual, the Chat GPT, everyone knows that, and we have image and video generation as well. So maybe you have played around it, maybe not, but there is something called stable diffusion, which is an open source image generator, and there's also DALI 3, which is OpenAI's model and also integrated into Bing image creator. And there's also Midjourney, which is quite popular for its artistic style. And as for audio and music generation, we have 11 Labs, popular voice cloning software, which creates really good your own voice clones, and even the existing, even without cloning, the text to speech is quite good with intonation and everything. There's also recently OpenAI voice engine that came out, but it's not released publicly, but it's more like announced. And then there is Udio and Suno.ai and all these companies which are creating music generators, which are also again super good. Like you wouldn't know that it's AI generated music until you know that it's AI generated. But yeah, as for code generation stuff, we have GitHub Copilot, Code Llama, and all these models. They're pretty good for autocomplete and just to get in basic stuff done, but not so great to completely replace you yet. So our job is still there, so don't worry. That, and in general, all of this Gen AI is basically based on LLMs, at least the text part, not the other modalities. We are concerned about text today. So text part is dependent on something called a large language model, which is a model which has been trained on internet scale data sets, terabytes and terabytes of data sets, like trillions of tokens, and they are really good at understanding language and generating human language. So generate the tokens based on the next token prediction. So they generate everything word by word. So let's say I generate large as the first word, then next word will be language based on the large, and now the model's word will be dependent on the previous two words. So this way it will depend on the previous generated text that has been generated so far to generate the next word or next token, to be specific. And it's based something on self-attention, which is basically a technique which allows the model to basically give attention or give particular attention to specific words in the sentence. So it's not like, so instead of depending on the entire sentence, let's say it already has generated 100 tokens, it won't really focus on all the 100 tokens. It will selectively focus on only the important ones. So that's how self-attention works. So the reason why it's called self-attention is because it's attending only on what it has already generated, and it's like with each other, like all the text is connected like quadratically with each every other word in the same sentence. So, and this is the systemic mechanism that has led to the creation of the transformer architecture, which is the backbone of every other LLM out there. We won't go into technical details of what transformer is or how it works or even how LLMs work. This is, I'm just giving you a bit of a background, a high level background, because our focus is application today, not the theory of it. But there are other webinars that Selstrat has already done and probably already scheduled in the future to for any of these. So yeah. But yeah, specifically, text generators are mostly something like a decoder only architecture. So given a sentence, they will generate the next word. So they just decode words. They take previously generated text or either as prompt like human input or anything that the model itself has generated, and to take that to generate the next word. So your GPT models and everything are all decoder only architectures. And yeah, life cycle of an LLM is, as I said, it's basically based on, like, you start with something called a pre-training, where you basically just dump a lot of text and ask it to just train it to just generate whatever data that you've provided. So it's not, it's unsupervised. There is no labels as such, but it's more like you're just generating the next word. Yeah. And then it goes to something called instruction fine tuning, where right now you are asking questions, right? You give it a prompt, you ask it questions, and then it responds. So to give that, to train the model to accept instructions, we do something called instruction fine tuning, which is basically supervised learning. You have some input and you have some output. And then alignment via human feedback is basically telling whether LLM is good or whether the response is good or bad, because both responses are valid. In this case, for example, both these text seem fine, but one is more verbose while one is not. So telling which one is better is helps us with creating a good LLM that aligns with human preferences. And we use these LLMs basically to create systems. So keeping all of the theory, all those life cycle, everything that I talked about apart, the point of an LLM is it's a language tool that you can use to basically do pretty much anything in terms of text. You can ask it questions, you can ask it to generate code, orchestrate process, act like a manager of different worker models or things like that, create like agents and stuff. So basic mind map of this is would be like, you have your LLM and there are a few things that you can do. Of course, you can create chatbots, but with chatbots, you can also do something called a retrieval augmented generation, um, which will basically allow you to create a chatbot on your own data without fine tuning or training. So that's key here. We are not fine tuning or training a new model. We are rather providing the model with relevant information in the prompt itself so that it can generate accurate answers based on that context that has been provided. Apart from that, we also have agents, which are basically models which can basically create an entire workflow, automate that. For example, you might have, if you're up to date with AI news, you might have heard of things like Devin, or even the new Copilot workspace. So all these models, what they do is they basically do a particular task. So there you're not chatting with it or anything, but you have tasked the agent to complete a task. It may be developing a software, it could be uh, going into a particular API, fetching some data, pre-processing it, creating an entire pipeline and processing all of that automatically. So agents are basically used for that, where there will be conditions, if else conditions, and like multiple states that it needs to go through. It's like a pipeline or AI pipeline sort of thing. Think of it like that. But today we are mainly focused on the retrieval augmented generation part. So yeah, so let me just start with overview of RAG. But before we go start with the overview of RAG, anyone has any questions? Open source text to voice models. Yeah, there is RVC, Suraj. There's a model called retrieval voice cloning or something like that. I think it's called RVC only or something along those lines, which is open source. There are a few open source text to voice models. Even NVIDIA has the text to voice models in its Nemo package. So yeah. With language. Okay. Okay. Yeah. Anyone has any questions so far? Also, let me know if I'm going too fast or anything. Because I just skimmed over the overview of that, but the goal was mostly to just give you a slight background and not delve into details. But all you really need to know is what ChatGPT is in order to be in this workshop. So that should be fine. What ChatGPT is and what LLM is. Sorry, what Python, how to use Python. Yeah. Okay, so we'll just get started with an overview of RAG. So first we'll talk about what. One second. Sorry. Yeah, I'll just hide all of these. Yeah. So we'll start with the what. So basically, it's the idea that LLMs don't have up-to-date information, right? So they have outdated information. You may have your internal company knowledge base, or you may have your own college notes or something that you wanna ask it. Or in general, LLMs are not accurate. They do something called hallucination. So if I ask it a question, it would hallucinate and create its own answer if it doesn't know it. It won't, because the LLM doesn't really know what it knows and doesn't know. It's more like we as humans know, but the LLM is not smart enough to know what is true and what is not true. So that's where hallucination comes in. So I'll just see. Yeah. So yeah. So I just asked GPT 3.5 that what is the Jamba model. So this is one of the research papers that came out last month. It's a hybrid between a transformer and something called a selective state space model. It's like fast and hybrid and stuff, but that's relevant. But this is a research concept or paper in AI that was not in the data set of this model. So if I ask it this, it will basically make up something which is not true. So it says it's a comprehensive framework. So if I specifically say in AI research, it should just make up something and give me an answer. So as you can see, it is saying something which is not true. So this is not what the Jamba model is. So this is what we refer to as hallucination. Now, it confidently gave the answer, but we, as humans, if we didn't already know what Jamba is, then we would blindly believe whatever the model spit out, right? And that's not ideal, right? That's why many people who go to ChatGPT for their assignments and homeworks and then they do it, they blindly believe it. I think you all in college might have that one friend who would just blindly believe whatever ChatGPT says, and when you recheck it from your end and you realize that whatever it spit out was nonsense. So yeah, so
Sorry,
sorry.
sorry to interrupt. Like, do you have set up at your left hand side? How did you set up all this?
No, it's the OpenAI website. The regular OpenAI website may it's running the API playground. It's the API playground that you can use to chat with different models. Like if you log into your OpenAI account. Like these are all the from the OpenAI website, all these features and stuff. Is that fine?
It is visual code. Sorry, continue.
Yeah. So this is what hallucination refers to. Now, if I had provided some context, so let me go to archive.org and search for the Jamba model. And I hope, yeah, joint hybrid transformer language model. Yeah, I need this. I go here and I copy this, actually this abstract, let's say, and I go back to my model. And now instead of this, I say something like this is background context. And now I ask it what is Jamba model. So let's remove all these messages. So let's say I gave it some background context, and now I'm asking it what is the Jamba model. Now it is correctly giving me the answer that Java model is a new large language model based on like I am five. Yeah, so just yeah. So it's basically giving accurate answers based on the context that you provided. So RAG is basically this: you are asking it a question, you are creating a chatbot essentially, but you're augmenting the knowledge of the LLM. You're like extending its knowledge to not just what it already knows from the pre-training that it had over the internet, but you're adding extra information, injecting extra information to the prompt itself. Maybe it could be your chat history or whatever, but in some form, you're adding extra information to the model in your prompt and then asking it questions based off of that. So this is what this is all this also something refers this is also like kind of in a sense a form of in context learning, because you're giving everything in context. You're not fine tuning or anything, but rather you're giving all of the information to the LLM upfront and then asking it questions based on that. So this is what retrieval augmented generation looks like. Now the retrieval part is that now this information that we provided here, right, this background context, this is not something that we would manually add to LLM, but rather have it automated. So when I ask, so yeah, let me go back to the flow chart here, this tab. So what would actually happen is that, so when I ask it like, okay, let me have this somewhere else. What is the Java model? So yeah, so let's say I have the question like, what is the Java model? So this is my question, and I ask the model this. Now what would happen is we would have a uh, RAG system, whatever. We'll talk about what exist exactly is inside the system. But let's assume that this is some black box system that we have, which will take this question, okay, and give me like some documents. So let's say I have a database. Let's say, yeah. So let's say I have a database of archive research papers, let's say, or something, a bunch of papers that I'm either manually added or I'm directly connecting to archive or something. So I take those and it basically goes to this database and returns me the most similar documents. So let's say this is the actual Jamba paper, and then there is also something similar has is connected to the Mamba paper. Sorry for the funny names, but these are true names. I'm not making that up. And then maybe SSM paper or something like that. So it gives me, let's say, the top three research papers that are similar to this question. Any questions? Okay, I'll just complete it and then I'll ask if you have any questions. So I have a question. I put it through RAG, which will be basically I'll just call it the retrieval system. So we'll talk about what it is really, but it will basically give me similar research papers from my knowledge base. So all these three papers, let's say I want to take only these two. And what I would do is I would then get the text information of that paper. So in this case, let's say this is my text. And similarly, let's say we have the Mamba paper as well. Where's the Mamba? Okay, I'll just take some random papers thing. So let's say this is Tramba, okay. But yeah, whatever it is. So I have this text, I have this text. Now what will happen is, now I would have my LLM here, let's say GPT-4. And this, what this would do is it would take this context and this context as well. And it would also then take my original question and then it would give me an answer. So in this case, it would be give me a second here. Yeah, so it would give me some answer like this. Let's call it LLM in brackets में GPTs, Claudes, Geminis. So all of our GPTs, Claude, Anthropic Claude, Geminis, all the different LLMs that we have, we can use any of those, and it goes there, and then we basically get a text output. So this answer is basically grounded based on the context that we have provided, and that context itself was retrieved dynamically using something called a retrieval system. So this is how it works. Any questions on this? I'll just go over here. If you want me to repeat this, let me know.
I had a question. You
Sure.
said the retrieval happens based on some similarity.
Yes.
Is that part of the retrieval system itself, or that's a totally different thing?
That's part of the retrieval system as a whole. Yeah. So we'll come to each of those components and steps that actually happen. But yeah, there is basically semantic similarity. So you do semantic search of this query in the knowledge base that you have. Uh, uh, like to be specific, it's actually the vector database that we'll be searching it through that we have already embedded and indexed. But yeah, to keep it simple to begin with, it's sort of think of it like a knowledge base. We would
Finding
semantic search.
similarity is the capability of the vector DB, right?
Yes.
I mean, if we have data, we don't have to reinvent the wheel.
Yeah, vector. We'll use a vector database. So in this today's workshop, we'll use Upstash to do that. But yeah,
Thanks.
there are different things like VV8, ChromaDB, even Postgres, Redis, and all these have their own vector versions as well now. But yeah, the vector DB will actually handle that. So this retrieval and all of this will sort of like a single system. I'm just showing it just to keep it whole thing. Any other questions? Hibernation retrieval system based on question, what we present in different formats. Retrieve based on question. Sorry, I didn't get you clearly, but if your question is based on any question in what do you mean by different formats? Can you elaborate, Shrikant? You can unmute and all talk as well. Okay, but based on what I sort of got is that yes, you can ask any question and it will give you the answer based where provided that similar documents are in the document DB. In the situation that there are no similar documents at all, then we would have to either set a threshold for similarity or we could just let it go to the LLM, but we'll give instructions to the LLM that if the question and the given context that was provided, for example, now the context is this, but my question was, uh, what is uh, what is Neuralink? Let's say is my question. Now this question is completely unrelated to what the retrieval system retrieved, right? Because this information was not present in my database. So the LLM should ideally just say that I don't have that information. The given context doesn't provide me that. So I have no idea what Neuralink is. So this is the expected behavior from our chatbot. If even if we ask a random question, it should say that it doesn't know it. It should not hallucinate and generate it and pretend it's one fake answer, but rather be aware that it's strictly follow the law that you should always answer based on the context. If the answer is not in the context, then that means that information is not present with you at all to begin with. I don't know if that was the question, but yeah, I hope that clears things in general a bit more. Any other questions? Or everything is clear?
Now you can continue.
Okay. You can also send a reaction if with thumbs up and stuff if you like to respond to
Okay.
questions like this. Yeah. So yeah, anyway, cool. So I hope so this is what the RAG, the idea of what RAG is and why we want to use RAG. So yeah, so we completed this what and why. So you can also think of RAG as your reading comprehension from school. So we had the section A in English exam. We would always have section A, which would have a paragraph and a bunch of questions below it, right? And we would answer those questions based on what the paragraph has. So RAG is basically that, except the paragraph is dynamic here. So if you have a question, you would actually have to find which paragraph the answer is from and then answer it. So yeah, so that is what and the why of RAG. Now how we are gonna go? So we are gonna look at a few components. So the first step is actually loading data. Yeah. So let's say you have a PDF. So in our case, we would have a PDF. So let's say we have a PDF document. So we'll be talking with a single document. I mean, you can do multiple as well. We'll actually make it so it can work with multiple documents as well. But to keep things simple for explanation, let's say we have a PDF of a paper, right? Now, what would happen to this paper is that we would break. Now, this paper may contain things like it could contain like 10,000 words or something, right? But you need to know something about LLMs is that they have a text limit on how much information they can process in a single turn. That is, they have something called a context limit. So in your prompt, you can only give a limited amount of context. And this context length increases as you go and continue the conversation. So it's even if, let's say, your context length is like your model has a context limit of 5,000 tokens, it doesn't mean that you're for only for one message that's 5,000. That's for the entire conversation that has been done with the chatbot so far. So in order to maintain that, we need to break this paper down into chunks so that it's logical for the model itself to only retrieve. So it may have a 10, 30, 40 paragraphs or 40 pages or something in the paper, but not all of those pages are relevant to answer your particular question, right? You only need one particular page from these 40 pages to answer the question. So the same case as your knowledge base, you have a bunch of papers, but and you only need your answer is only in one of them. So the same case, but at a paper level. So you have a bunch of let's say it has 30 pages, but your answer may lie only in one of those pages. So in order to do that, we would actually read the PDF and we would chunk it. So we would split it based on any kind of logic. So there are different logics like paragraph level splitting, sentence level splitting. There's also character level splitting. That's like the simplest. You have like you split it into, let's say, first 1,000 characters, or let's say first 100 words to keep it simple. First 100 words, and then the next 100 words, and then next 100 words, and so on. So it basically split this entire document into into different chunks. Yeah. So this entire paper or document, PDF, whatever that is, it is split into multiple chunks so that when we ask a question, only one of those chunks might have an answer, or maybe two of them might have an answer. So we can reliably scale this system so that it doesn't run out of context length to answer your question. So for example, the GPT model, yeah, 1 second, sorry. Sh- yeah, sorry. Yeah, so for example, the GPT-4 model, okay, 1 second. For example, the GPT-4 model that we have, that has a context length of limit of 128,000 tokens, and it has training data of up to December 2023. So anything beyond, so anything from 2024, it won't be able to answer, and that is why we need RAG. One of the reasons it won't have the latest information. And if we go to GPT-3, where's GPT-3? Yeah, GPT-3 has a limit of 16,385 tokens and so forth. Similarly, if we go to Claude or anything like that, uh, let's go to Anthropic AI. Yeah, so if we go to Claude, all of these models have a 200,000 token limit, I believe. The API. Yeah, all of the three Claude 3 models are 200,000 tokens, so obviously longer than GPT. Uh, But yeah, there's a trade-off between accuracy and all that stuff as well when it comes to increasing token windows. And these are all token windows that the models have been trained on. Now there is also a possibility that, let's say you already have a model which has 8,000 token limit. You could potentially use some techniques to kind of slightly fine tune it and improve the context window from 8,000 to maybe 1 million tokens. That is possible. So there are different techniques like rope, which basically increase the context window limit using caching and chunking and group query attention and a bunch of other optimizations they use to sort of hack their way into increasing the context window. But that's not true context window long, but it's more like a hacked way. It works fine, but it's not trained on that long, so it may not be as accurate as the native versions. But yeah,
And what was that again? Rope, you said?
yeah, I think it's called rope method to extend context limit. I'll just pull that up. Yeah. So it's rethinking rotary positions. Yeah. So yeah, it's just rope. Yeah. Rope extension, long LM. Yeah. Okay. Anyway. But yeah, it's basically an extension method to basically increase token limits. So even the Llama 3 model that just came out, right, a couple weeks back. So they increased the token limit to a long window. I think they reached 1 million. I think that's the world record or something. Not sure about how accurate that is, but uh, theoretically, yes, you can increase it, but you would trade off accuracy as well. So this is called a needle in a haystack problem. So as your context window increases, if the model has to respond with something that's hidden within that enormous text chunk of text that's already there, it might struggle. So that's called needle in a haystack. So so regardless of how long you go, you need to have your needle in the haystack scores good and well, so that it makes sense. So that's why even if you have ever increasing context windows, RAG processor is more focused, so it would be more reliable than uh, long context. Although there are some arguments for long context as well, but we won't get into it too much here. But yeah, we have to, yeah. So okay, yeah. So this is the first step, is breaking down the paper and chunking it into different windows of, let's say, 100 words or something like that. We would also have overlap, so that then with this window and this window has like 10 words overlapping, so that if there are sentences, like if they're middle of the sentence cutoffs, there is some like kind of overlap, so that it's sort of retained. So in order to even not have that issue, there's also semantic chunking, which will do based on semantic similarity between text, between sentences, to cluster them together. And then there's also sentence retrieval, which will do it at a sentence level, and so that there are no mid-sentence breakoffs. So there are different ways to chunk and split the text of your document, but we'll be sticking to a simple idea that PDF of a research paper is usually structured, right? There is headings, subheadings, abstract, conclusion, etc. So we can convert that into Markdown, and then take each of the Markdown sections, and then we can further break it down into the desired size of chunks. Because let's say a particular section is really long, you might still need to break it down. So we'd have some logical level of breakdown in this scenario because it's structured to some degree. So yeah, so the first part is basically loading data, which include getting the text, list, okay, which includes getting the text and splitting it, splitting or chunking it basically. What? So this is the first stage of your thing. Also, actually, this would actually sort of come under the something called the ingestion pipeline. So we can call it ingestion, we can call it indexing, anything, but we'll just go with normal terminology. So our loading, so this is the first stage, is loading the paper. So do you guys wanna start the coding, and as we go through it, we'll add more components and code that, so that it's so that we have a mix of this diagrammatic theory as well as coding. You can
Really
both.
depends on how long this is going to take for the overview. If the overview is not going to take a very long time beyond this, then I like this. Otherwise, we can.
Okay. So okay, so I'll just give a high level overview, and then as we go into the code, we'll dive into each thing, each step anyway, and detail. So okay, I'll just quickly complete slide of nowhere. So yeah. So okay. So after the ingestion, after we load the data, we would embed it. So we would do something called an embedding. So embedding is basically a way where you can take a bit of text and basically convert it into numbers, because at the end of the day LLMs are all mathematical models in a sense, so they all work with numbers only. So we need to convert our text into some in a way that is understandable by the model. So we convert it into vectors called embedding vectors. And yeah, we use something called an embedding model. So there are different embedding models available. Some open source ones are from the sentence transformers catalog. You will find a bunch of models there. And some popular open source embedding models right now are the BGE series. So BGE small, BGE large, and all these. And as for the open source ones, the OpenAI ones also have an embedding model. The same goes with Cohere. There's a company called Cohere. And in general, if you go to AWS Bedrock, you'll find a lot such embedding models from different providers for use cases. But yeah, so we would convert into embedding. But after that embedding, what we'll do is we would actually index it into a vector database. So what this vector database does is it allows us to do semantic search of our search query, which again would be converted to an embedding, and match that embedding with every other vector embedding of our chunks here. So this all of our chunks are basically what are embedded basically. So it's not anything random, but your chunks that we just created, right? So all these chunks, we would turn them into an embedding and put them into a vector database. So this is what the embedding stage is. So this is mostly done with our ingestion pipeline. That is, we are ingesting information and putting it into a format so that when we ask when we ask a query to the chatbot, it will be readily able to search through the knowledge base and give us fast answers. So our priority here is latency, is speed, so that we can quickly get an answer. And that's why embedding vectors are all, that's why vector database are actually quite good for embeddings, because they do a dot product, and dot product is quite fast in general on a GPU and all. So you don't really
Are
need to do,
questions also embedded?
yes, question will also be embedded. So you would take your question, you would embed that, and then you will compare that embedding to every other embedding in the vector database to find out the most relevant ones. So it's not a linear search or a binary search sort of thing. It's more like a dot product, and you directly get similarity scores like cosine similarity or Euclidean distance between the vectors, because it's all numbers. So we can make use of that. Somebody has raised a hand. Yeah.
So Bhavesh, I have one question.
Yeah.
So in vector database, I mean index vector database. So which one we are going to use, like sparse matrix or dense matrix? Why and when to use?
So mostly the service providers kind of take care of that. Dense matrix is fine when your database length is not that big. Sparse is obviously for scalability. The point of a sparse database is so that your system is very scalable to millions and millions of records. And yeah, so I mean that's the main difference between them. The only reason you would switch between different types of databases based on this. Usually your service provider, the vector database provider, will take care of that. But yeah, there are like different
So
methods like DSCN and
is
stuff.
there any
Yeah.
way to identify like cost wise or performance wise, and how we are going to identify so which one is the right for our use case or
Uh,
domain?
I mean, one is of course pricing. You can compare your pricing. You can compare the accuracy. So now retrieval is approximated. It's not gonna be exact, most similar directly, because in order to scale, they make use of some heuristics so that it's like approximately closest to your query, not actually closest, for scalability reasons and speed reasons. So you'd have to actually just have a evaluation set with you, run retrieval, and find out whether the retrieved chunks are actually the relevant ones or not. So there are evaluation metrics for that. So there's a this would be your retrieval evaluation metric. There are tools like TrueLens that you can use to actually do that, and even Langsmith has evaluation stuff there. Yeah, almost every major library has integrations with evaluation services like TrueLens or Deep Evals and all these. But yeah, you'll have to do a performance. Also, speed is also, if accuracy is really more important, then you can let go of speed and work on accuracy and find out which DB is the most accurate for your use case. But if you need a balance, then you'll have to do a bit of a hit and trial to find out those. And it's probably like anyone, if you search, I think people might have done that research already for you, and you probably could get that to begin with.
Question. So
Yeah.
why is cosine similarity used? Can you give intuition behind that? Because two vectors can be like far off in the Euclidean space, and still cosine similarity can be very high. So
Yeah.
can you give intuition why it works?
So there is actually there's one thing that I think people kind of skip, that is that when you train an embedding model, right, you actually predefine or pre-decide which distance metric you want. If you decide that it's going to be cosine similarity, your model will be optimized for cosine similarity only. It won't be optimized for Euclidean. So even if you use the embedding vectors and use a Euclidean, it may not work that well because the model originally was trained with cosine similarity. So one thing is, it actually depends on how the embedding model was trained. So if you go to sentence transformers catalog, you would find that which models are compatible with which distance metrics. Let me see if I can quickly pull that up. But train models. Okay. I know there used to be a while back a comparison of models. But yeah, but models are basically trained along with their query. That is one. And as for the fact why only Euclidean or cosine are used, this one is cosine is actually quite fast to do with directly like a dot product, because when you are doing dot product, right, cosine similarity is basically the dot product, just a variation of it mathematically speaking. But it's much easier to do a dot product than to actually do a Euclidean. So if you do a dot product, it's basically equivalent to doing a cosine similarity. So for speed reasons, that's also like one of the reasons that you would use cosine similarity. And also it's also the direction. It's not just the space where they're distance wise, not Euclidean, straight up Euclidean distance, but also the direction, which is because we are doing semantic similarity, right? We are not doing, for example, let's say in one particular space, two things, let's say apple and a okay, let's say apple and potato, they might be similar in one space when we think about it, like intuitively speaking, like they both are things that we eat, and one is a fruit and one is a vegetable, not technically a vegetable, but it's one of those categories that you would use. And now, so that's similar in that sense, but it's also not similar in the other sense, like depending on context you will provide. For example, if you add things like if you're doing potato, banana, and tomato, so your apple will only be similar to banana in that sense, because it's both are fruits. They will be more similar direction wise, even though distance wise they all might cluster together in the same area. I don't know if that makes sense.
So no, my question is basically that, like, why cosine was even chosen? Because meaning, okay, speed is one thing, but there would be a trade-off definitely. Meaning, just Euclidean, that space and cluster things together. Meaning, from there,
Okay.
why did anybody move to cosine, and why does it even work?
Oh, okay. So, I mean, I don't have a direct answer to that. So, sorry, but because like even I don't exactly know. You're basically saying why it was chosen, like at a fundamental level, right?
Yes. Yeah.
Yeah, so I don't have a clear answer to that either. I just know the application-based things, like it's faster and it's like it scales quite well and it's efficient and it's also quite interpretable and stuff. But like mathematically, it's quite useful and more like benefit. It has mathematical benefits. Like it can even operate on normalized vectors. So it's not because, for example, Euclidean would take absolute values, but cosine similarity is directional, right, in nature. So it won't matter what the absolute value is. It would be more like direction wise. So even if, let's say, you are, for example, there is a thing called embedding compression in this sense, where let's say you are, because when you scale, right, your vector database, your vector embedding dimension could be, let's say, 1024 uh, is your size of your each vector. But as you scale, that will become very storage heavy as well and more computationally expensive. So you can compress that vector by normalizing it into, let's say, 384 or something like that. So when you do that, cosine similarity will still work with that. That's sort of like an advantage to it over Euclidean. I mean, even Euclidean sort of might work, but it works better when cases like with normalization and all that stuff. It's more
Okay.
robust.
Thank you. Thank you.
Yeah, sorry, I couldn't give a direct answer, but this like mathematically, this was. Okay, so let's work with. Uh, yeah, someone also gave an example of the addition subtraction thingy that works with well cosine as well, like when your models, when your embeddings are fine tuned for that. But yeah, okay. Moving forward, moving forward. Yeah, so we'll have our embedding will index into a vector data. So this would be an ingestion. Now the next question, next stage would be retrieval, which would basically start with just embedding the query. Yeah, embedding the query and then pushing it to the vector database, comparing it from in the vector database.
Bhavesh, I
Yeah,
just want a small question.
yeah.
Uh, Suppose if I have a million vectors and I put in a vector to search for, so does it do dot product for every vector in the database, or how does
So
it
yeah,
start?
so the naive approach is that you would do a dot product with every million records in the database, which is obviously not scalable because the more the numbers, the more computationally expensive it gets, the more memory requirements and stuff. So in reality, what it does is it does a nearest neighbor search.
Okay.
So let's say let's say you divide your database into clusters of nearest neighbors. And when you're doing a query, comparing the query, you're actually comparing it with the nearest neighbor cluster. And then once you go into that cluster, then you will do the dot product with everything inside.
Okay.
So specifically, they use something called disk ANN. Usually, it operates directly on disk, so memory requirements are less. And ANN because it's called approximate nearest neighbor. So it won't be the actual nearest neighbor, but it's more like approximate in that sense. And that's because of the clustering and all those things. But yeah.
Yeah.
Okay, cool. Okay, so comparing it, yeah. So retrieval stage will basically be embedding the query and compare it in the vector database and getting the top k chunks or nodes or documents, whatever you want to call it, it's just terminology. But whatever your text is, you just get the top k of that. So let's say top 3 or top 5 or something like that based on similarity. So this will be a retrieval stage. And now the last stage would be um, response generation or synthesis, whatever you want to call it. So this stage would be simply adding this retrieved, adding these retrieved chunks to the LLM context or the LLM prompt, let's say. Yeah, and then asking the LLM to answer the question based on the query, based on the context, sorry. not query, context. So these are all the 3 stages of RAG. Any questions here? Anything else? So if everything's fine, we can proceed with yeah, we can proceed with the hands-on stuff. So we'll start first with the development. So let's get to it. I'll just share the collab link in a bit. Give me a second here. Just give me a second.
So Bhavesh, you are using Gemini model or any other? I mean, for LLM.
Yeah, for today's thing, we'll be using OpenAI's GPT 3.5. But yes, you are free to use any other model if you want to. It's just changing just the
Yeah,
code of
syntax,
it.
semantics.
But
Yes.
but if you want to stay consistent and follow along quickly, then you can use the OpenAI ones. But yeah, you're free to use Claude or Gemini or anything else. So I've been just adding a few environment variables here. So one thing is, does everyone, or at least many of you, have an OpenAI account here? Or have you signed up for the OpenAI account? Okay. Yeah, so I hope it's all active and running, because yeah. Also, I would like you to go to a website called upstash.com. I'll just paste the link in the chat. So I'll just show what upstash.com really means here. So it's basically a serverless data platform. I mean, what I just read it there, but it's basically a service which provides us serverless access to different services like Redis, Kafka, uh, and Vector, which is of our interest here. So normally we would need to spin your own clusters on AWS and stuff with Redis and Kafka and all that stuff, right? Which is a hassle, and you only also you have to pay a lot as well. So this is a serverless, as in you only pay for the requests you make. So that is quite advantageous to us. So we'll use the Vector feature of that. So you can basically go to the Vector and basically create an index here. So just create an account. It's a free thing. So you can just go to, okay, let me just log out. You can just click on login, and you can log in with your Google account, even Amazon, I guess, and GitHub account, whatever, or you can just directly do that, and it should allow you to log in directly. So pretty straightforward to create the account. So just do that as well. And yeah, let me share you the, so you would, okay, just putting out those stuff.
This will create only index.
Yeah, this will create only the index. Yes.
We can't see the data.
I mean, in a way, you can see the data if you want. I mean, if you go to the data browser, you can see all of the embeddings here. And if you added the original text as metadata, then you will be able to see that as well. So I added text and the doc ID, as in what document name it belongs to.
Okay, it's
So
very
text
nice.
and doc ID. Yeah. So you will be able to do that. I mean, under the hood, it's still running on AWS. But yeah, it's provided to us as a serverless service, so it's easier than other vector databases, because then the other open source ones you'll have to host yourself. Pinecone again is a storage based thing, and it runs always and not that thing, and this is more convenient to use, I would say. I mean, I also used it for the first time this project, because I wanted to actually use it for a long time, and I finally got to it. So Okay, let's see. Let anyone with the link can view. So I'll just share a document. Where's Gmeet? Yeah, so I shared you guys a collab link. So just go to that link and you should be able to see this. Also, if you go to that collab link, general, I want, let's say I'm from a different account. Oh. Paper chart. Yeah. So when you open up this collab notebook, you would see something called copy to drive. So click on that because this is a view only link that I shared and it won't be saved in your Google account. So click on copy to drive and then it will create a copy of this notebook so that you can have your own version of it. So yeah, also let me know when you're ready to start. Yeah, because we will be starting now. So you can just click on connect. Also, can I get a reaction on who is following along and who is, yeah, I just want to know like how many of you are actually to do. Okay, yeah, cool. Jayapana, do you have a question or you just was answering to the fact you're doing? Okay, got it. Yeah, okay, so let's begin. So the first step is just cloning the GitHub repository. So the GitHub repository is just this actually. So not much readme here, but it's basically this notebook that we are actually running right now in Collab. So I've just set it up in Collab here so that it's easier for you guys to run. There will be one point where we would actually kind of need either a local system with your AWS CLI configured, or you'll have to again configure it in your Collab itself. But yeah, we'll just work and go and we'll see where we reach. Okay, so let's, yeah, so just clone the repo and on the left, you see this file browser, you'll be able to see the repo here. And this will basically allow us to change directly into this repo. So the first stage is actually installing a few things. So there is a requirements.txt here. So just add an cell and just do pip install before you run anything else. Pip install requirements.txt. You can remove the exclamation. So just do this once. So we can make sure that we have all the libraries that we really need. So it is basically installing OpenAI. This is just the .n file. Upstash Vector, PyMoBDF, LangChain text splitters, and tick token. So this we'll use for chunking and stuff. So yeah. So we won't use any big LangChain abstractions or anything. We'll keep it simple and directly use good old Python. Python will only use LangChain for the splitting of the text. That's the only reason that we'll be using it. So yeah, so once this is done, you can now go to the development section and you'll see a statistical ingestion and where we'll start with the imports. So let's start with the import. So just run the first cell. Now this is the place where you need to actually put your API keys. So in the OpenAI API key, you would put your OpenAI key. And in these two, we would actually put our Upstash things here. So we'll come to that later. So you can ignore these two for now. So just let it, like just ignore it there. comment it out. We'll put our OpenAI key. So let me put mine. Yeah. Yeah. So we just put our OpenAI API key and run it. So this is just so in our environment variable, the key is there so that when we use OpenAI, it will directly fetch the key from there. So the next stage is actually loading the PDF. So if you see on the left, there are a bunch of sample PDFs that I've already put there, a bunch of papers here. So this is a very big paper. These are the Jamba Mamba, and these are some 2 small papers, Craft Assist and Peer Cloning via Search, PPT. So these, so you can use your own archive PDFs if you want to begin with. But anyway, when we finally build the chatbot and everything, you can use any archive research paper. So it should be fine. So yeah, so let's start with this. So we'll start with this. And what this is going to do is the FIDS is basically our PDF reader. It's the PyMu PDF library. It's just imported as FIDS for some reason. So we just do that. And so if you just click on PDF doc, or just open that up. If I go to the first page of it, you can see page 0. And if I just do get text, I can get the text from the first page. So all of the text. So this is the first page of the PDF. But all of this is quite unstructured, frankly. So what we can do is we can convert all of this into Markdown. So to convert that into Markdown, there is a small, so PyMove PDF has provided us with a small library, not library, a small function or like a script, which allows us to convert any PDF file into Markdown. So you all know Markdown, right? This simple GitHub readme documents we write in Markdown, right? So it will allow us to separate out the text in a structured way. So if you look at, so this pdf.md to Markdown will basically convert it to Markdown text. If you look at Markdown text, you can see, let me just print it. So if you look at Markdown text, you can see it's a slightly more structured version of what we had before. Previously, everything was all cluttered and clustered together. Now we have like headers. So this is like a header 2, this is header 3, and we have abstract bolded, and then we have a section called introduction, and it's all structured, right? So this allows us to chunk our document section wise or even paragraph wise, right? So this would be helpful to us. So that's why we converted our PDF into Markdown. Any questions here? Okay, well, I think not. So next thing is breaking down the Markdown headers based on headers. I mean, that's what the point of Markdown was, so that we can split it based on the header sections. So LangChain has Markdown header text splitter that we'll be using here for that. So we have our Markdown raw text here. We'll just put it, we'll specify what all headers do we want to split it on. We pass that, like we need to split on header 1 and all the way up to level 3. And we want to split the text. So we'll just, once we initialize that, we'll just use the split text function to do that. And also strip headers as in, it will keep the headers within the text so that we also know what the title of that chunk or the section is, as in it won't remove it. So once you split it, as you can see, you have 10 splits, and let's take a look at one of them. So as you can see, we have something called a document object, which has page content, which is the behavioral cloning section with, I think, the authors and stuff. And then we have header 2, and then we have some metadata associated with it, like header 2 and header 3 or things like that. Now, obviously, this Markdown parsing is not accurate enough because this is actually not a header. This is actually just an author text, but based on heuristics. So because parsing a PDF is still quite a challenging task. So it's not solved as such. So I think a few people have some questions. Yeah, go on.
So my question is, could you scroll up a bit, please?
Yeah.
Right. So what's the point in putting that 1 hash and 2 hash and 3 hashes?
So, okay. So let me show you. Okay, so let's say, okay, let me show you all of the header splitters. Okay. So, okay. So as you can see, there is a document which is split on section header 2, that is double hash. And then there is a section which is split on triple hash. And if you go to, there will be an introduction, yeah, triple hash. Now let's say I remove this thing. I view it again. I won't have the triple hashes. I will only have the double hashes. So this is one document. And yeah, I won't have any other level beyond double hash. Yeah, it's just header 2.
Like how this hash
Yeah,
thing is.
also, as you can see, there's just one because the root of was double header. So there's nothing got split. So that's why we are adding more sections to split it, more levels. Sorry, yeah, go on.
How this headers, like how in the document it is able to read that, okay, this is header.
Yeah, so that's the markdown thing that was used here. So the two markdown script basically helped us convert that into markdown. So again, that was based on a heuristic. It's not totally accurate. So ideally it should have been first header 1, but it basically has a bunch of conditions to check whether something is a block of text or not. So there is one thing, PyMu PDF is a good library because it allows us to split the PDF into different blocks of text. It allows us to extract figures and everything. So we can actually do it on our own as well. We can find that the first block is basically abstract. The next block first only if it's just a one line and it comes before a block of text, it's probably a header. So things like that. So we have rules set here in this script, which allows us to basically get the headers. Also, research papers also tend to have a table of contents that also allows us to at least start with having all the list of headers beforehand and then match the block of text to those headers and
So
divide them into sections.
this file, like PDF to MD, this is you have written it or it is readily available? Like,
This script is readily available. So
okay.
this is built. This is a script made by the people from PyMu PDF, the library that we are using to actually open this PDF. So this fits thing, it's actually this library. So they have provided it. So I was actually doing custom parsing as well, but that got too complicated. So it is there. I have not put it in the GitHub, but so when we get to that point, I guess I can all at the end, maybe if we have time, I can show you how that parsing is done at a lower level if we do it from scratch. But that is taken care for us right now, so we don't need to worry about that as of now.
Okay.
Okay. Cool. Okay, so yeah, so this is our header space. So as you can see, if we didn't put header 3, yeah.
Yeah, can you show me again the requirement.txt file? And where are you executing that?
Executing that here. So you need to add that code. Actually, that's not in the collab. So just after this, add a new cell with pip install our requirements.
Okay, got it.
Yeah. Also, 1 second. Actually, let me run it in my this thing actually, so that if I make any changes and if I save it and if you refresh it, you'll be able to see the updated code. Stop. Okay, not here. I mean, if you originally refresh the link, you will be able to see updated code if there are any changes. While you write, you can and then paste it in your duplicate copy that you have. But yeah, anyway. And I'll just put my OpenAI key. That's fine. No module named, huh? Just restart it. Why is this weird? Okay. Just give me a second here. I don't know why my own notebook is not working.
So where is this notebook available? On which link?
On the chat, it's pinned. The Meet
I'm
chat.
unable to see the chat window.
Sorry?
I'm unable to see the chat window. Not sure
On the
about.
bottom right, you should see a icon, like second to last icon, I guess. There's a chat icon in your Google Meet.
Not visible to me.
I mean, it's you're on Google Meet only, right? I mean,
Yes,
you know,
yes.
you're on Google Meet. So on the bottom right, you see there's a meeting details. Let me just
It's in call message, share screen, show captions.
bottom, सबसे bottom right, extreme bottom right. You should also, I sent a message. You would have seen a pop up, and you can click on it to navigate to the messages.
Okay, let's check this.
Yeah. Anyway, while that runs, this. Why? This is so weird. Why is this not working? Just ran it. Yeah. Think it was working in the other notebook. So I'll just go there nevertheless. Okay, anyway, yeah, never mind. Okay, so we have loaded our things. We have loaded a text. We have got the splits. So now we can see, because we have 10 sections, or at least that is what the model thing or the script thinks, that it should be split into 10 sections. So if we look at any of one of them, or any other one of them, let's say we'll go to 3, 4. Yeah, as you can see, there's an abstract section that we got kind of from it, and we should get an introduction section as well. Yeah, so this is the entire introduction section. So this is how our Markdown header splits look. Now there will be an issue that some sections might be very long, right? And as we already discussed, that every model has a token context length limit. So we only could use some amount of tokens. So for that, we need to further split these section-wise chunks that we got recursively based on chunk size. So we'll use, and we also need to count tokens. So we want to count tokens, not just do character level split. So we'll use something called a recursive character text splitter, which will basically recursively split the chunks until the size, the desired chunk length or is met. And in this case, because we want to split based on tokens, we'll use from tick token encoder. We'll pass in the encoder name, and we'll have like 300 tokens as the chunk and an overlap of 30. So the chunks will so two adjacent chunks will have 30 tokens common. So the first chunk will have it at the end, the next chunk will have it at the beginning. So this will, so now as you can see, originally the splits were 10. Now our total number of splits have become 20. So if you look at any one of
So,
them, yeah,
does the 300 chunk size?
yeah,
So does it take into account the tokens, not the words, right? Because
yeah,
it
the
is
tokens, yes, not the words.
okay. So it will chunk based on the subwords. Okay.
Yeah, yes. So that will be the split. So this particular document doesn't have any big sections as such. It's a small thing. So if I think if I go to the RAG thing, this has like a big paper, so longer PDFs. So as you can see, even splitting it at this level, we got like 2 headers. So the markdown conversion wasn't perfect as such. So we would probably split it, and as you can see, we from 2 to our splits got to 84 for this particular paper. So depending on the PDF and all, everything has a different structure and stuff. So that's why it's ideally even if we do markdown level splitting, we need to break it down further into recursive text-based splits, into token length-based splits. We can actually do directly as well. We can ignore the markdown sections, but for smaller papers, that works quite well. For bigger papers, this will work better. So yeah. Anyway, we'll just start with what all the existing code is. Okay, so that is that. So that's actually that. We have loaded our PDF. We have split them into chunks. So our first task of loading data and getting the text and splitting and chunking it is done. Now we'll go to the next task, that is embedding them. So to embed them, we'll use OpenAI. So if I just run this cell, so if you have put your OpenAI key as I have here, it should run for you as well. So put your OpenAI key here and yeah, put your OpenAI key here, and it should run directly for you. And yeah, also, and then we'll use basically embeddings.create, and we can just provide some input text. We can select a model. So in this case, we'll be selecting the text embedding 3 small model. And if you run that, you will basically get a vector. So this is what the vector looks like. It's a bunch of numbers. So if I look at the length of it, if I look at the length of this, it should be around 1536. Yes. So this is the length. So by the way, your response object that we got from OpenAI looks something like this. So our embedding was only under the data section of it. So it can also take a list of sentences. For testing purpose, we just passed in a single sentence, but you can pass in a list of sentences as well. And in fact, in our code, we'll be actually passing single sentences only just to keep it simple. But ideally, you should not do that. You should actually do batching. You should batch your chunks into, let's say, batch size of 10 or 20 or something like that, and then pass them as a batch instead of what we are doing here. So the next stage is basically going through our splits. So all of the splitted text that we have, chunks that we have, we'll split them one by one using a loop and put them into a dictionary sort of thing with our ID as just the index or something. We'll work on the ID later. The embedding and some metadata to go with it. The metadata is basically the text that the embedding is made of. So we'll just do that, and this will basically run one by one in a loop. Now, again, I have also added a note here that this is not the good way to do it because this is slow. For smaller length of chunks, this is fine, but when you have big documents and all, you want to process it in a batch so that it's faster for one reason. Yeah, so that mostly the fast is the reason. The speed is the problem here.
Bhavesh, one comment. Actually, when I trying the OpenAI, I'm getting the quota exceeded thing, right?
Yeah.
So what to do means, should I change the account or what's that?
Yeah, maybe you can try a different account, or maybe you ran out of the free credits that they gave in the beginning. If your open account is quite old, it will like more than 3 months. It would the trial credits might have expired. So either you would have to add your credit card and change it to a paid account, or use a different account maybe with a different phone number and email. Like both have to be different. So that is that. So that's why I mean that is one issue. That's why actually also that's one of the reasons why we're doing it one by one, because on the free OpenAI account you only get like the batch size of 1, I think, at a time. So 1, or it's quite less, I think 5 or something like that. So yeah, so you'll have to probably have a new different account. Yeah. So yeah, so this is so this is the chunking. So if we look at the chunks, we will be able to see them. And where is this? So as you can see, there are a lot of chunks. Yeah, so we have embedding. Okay, actually, let's just do one thing. We have the embeddings, and once we also have the embeddings, we also have the metadata to go with it. That is text and other stuff. We will add more stuff to it, but yeah. So this is our chunks, and this takes us to this embedding part done. But the next part is we need to embed it. Now to index it into a vector database, we will actually go to Upstash. So far, those who were going along, running the code along, were you able to run it till that point? Are you able to like run it till the embed PDF nodes point? Unless you have a quota exceeded error, which in that case, either you just get a different account or turn it into a paid account. I mean, paid, maybe it's like quite cheap only. It's like prepaid sort of thing. So you can just put in like 100 rupees or something like that to work with it, I think. But yeah, so yeah, before we move on to, before we even run this code, we actually need to put our environment variables here. That is the Upstash Vector REST URL and the token here. So to do that, we would actually need to go to Upstash, and let me go to Vector. Yeah, so there'll be 4 tabs here. We want the vector database, so we'll click on vector, and you can create an index, and you can call it something. So I'll just call it paper chat. I'll just call it workshop again. You can select a region if you want, doesn't really matter. The embedding model, you can also actually let the Upstash people handle the embedding for you by using one of the open source embedding models. So these were the ones that I was referring to, BGE ones, quite good. And I think this is also one of the top ones right now. So these are all fine, but because we are using OpenAI embeddings, you can click on custom and we'll pass our embeddings directly. And in general, having an option to change our embedding model is quite nice to have, I guess. But yeah, and you can change the metric here as well. So cosine, euclidean, dot product. Dot product is just a special case of cosine. So, but yeah, OpenAI embeddings were trained for cosine similarities, so we'll use cosine. No need to change here. Because this is the dimension that we are expecting from OpenAI, right? So as we saw here, we were able to, yeah, 1536 is our, 1536 is our embedding dimension here. So that is the dimension that we will be setting here. So that is one, and then we click on next, and then we select the free plan, and then we click on create. So on the free plan, you have like 20,000 requests, updates or queries that you can make into the index. So 10,000 updates and 10,000 queries, and a bandwidth of 50 GB and some storage. And I think 1.4 lakhs of index vectors that you can store. So once you go there, once you create your index, you will see an endpoint. So this will be, so you need to make note of your endpoint as well as the token. So just click on copy here, go back to your collab, and let's scroll up to the top. And then we'll put in our Upstash REST URL. So this is the URL or where we are going to make our, where we're going to hit the request to call and make a API call and index our vectors. And similarly, we'll copy our token and paste our token here. There's a long token. That's it. And then we just run this cell again. Just clicking on this run will do that. And once we, I think someone raised something.
Yeah. So could you go back to that page again? Vector. Yeah. Is that token going to be secret, or
Yeah, that's your secret token.
Okay.
I mean, you just copy it and it should work.
Can you tell me the settings again? What things have you had to create?
Settings are actually default, but let me show you again. So when you create index, just give it a name.
Yeah.
And that's it. Actually, next. So all of this is default, and because OpenAI supports 1536 and is also set to custom, everything like we didn't change anything as such. So you can just give it a name, go to the free plan again. No changes here, and just click on create.
Okay.
Yeah.
Thank you.
So after that, you will just get your endpoints and tokens here that you can just copy and paste it in the environment variables at the top here. So your vector REST URL and the Upstash Vector REST token. So these you will use to connect to the vector DB. So yeah,
Okay.
so once we do that, we actually just need to initiate it, and we can do import from Upstash Vector. You can import index and do index.from environment, and that's it. Actually, that's it we need to do, and that just kind of helps us connect it. It's just a single liner. And now what we can do is we can take all of our chunks, run them in a loop. Also, I'm adding the doc ID. By the way, doc ID here is basically just the file name, really, at this point. But eventually, like, we can change it as you turn it, take it into production stuff. We would actually want to give it a unique ID instead of the file name. But yeah, doc ID is basically that, and then we basically take all of our chunks and turn them into vector objects. Like, we're just storing it as a vector object. It's just a dictionary in that sense. With our ID chunk ID, we're also going to use the doc ID as a prefix, and then chunk ID as the original ID, which was just numbers, to be fair honest. So it was just chunk 0 if I do, and if I do dot ID, I mean, if I get the ID key, yeah, it's just 0 and 1 and so forth. So if I do 1, it's just 1. So it's just indexes. Chunks are basically that. And because it's related to a document, we just named our chunk ID as prefixing it to the document ID and then suffixing it with the chunk ID. And we would actually use that because when we create the vector, it needs three things. It needs the ID, it needs the vector, that is the embedding, OpenAI embeddings that we have already created, and it needs the metadata. So in the metadata, we can add things like it could be a dictionary of text, your document ID, and things like that. So in our case, we are adding the document ID as well to the metadata. You can add any other things. You can add categories. So the idea of metadata is that if you have millions of records, right, you don't want to rely on the nearest neighbor search to find it, right? It's actually more efficient if you can actually filter out specific things. For example, you have categories. Let's say like you have a bunch of news articles and you want to query from a particular news article. So instead of just putting in your query and querying it across all the million records, you can actually use metadata filters that you've already set yourself as category. Let's say like science, business, technology, finance, or something like that. So, and the vector database will only query amongst those filters, amongst those subset of the million records based on the metadata query that metadata filter that you set. So we are not doing any metadata filtering today, but this is something that you should know that almost all major vector databases have metadata filtering today. So you can use metadata filtering to actually make it more efficient. For example, you might use metadata filters to do security levels. So for example, some user has a particular role, only those people, they can only get access to certain data, or maybe you are doing user level. So you can have user ID, for example, have a single vector database, but split it, use user IDs as metadata to actually retrieve information only from their user account. So those things you can do with this. So metadata filter will actually help you with that. So yeah, and that's it actually. So if we look at one of the vectors, it's just a vector object with again the vector. Like if we do the dot ID, we'll be able to see the ID. And if we do metadata, it's just a dictionary of text and documentation, doc ID, which we use. Yeah. So in general, you can, for example, in your chat, you would say that you only want to get answers from a particular set of documents. So you can use doc ID based metadata filtering for that. But yeah, anyways, so once we create our vectors, now it's just inserting those vectors into the DB, which is a simple single line code of index.upsert. So it just updates or inserts within the database. So if it's the chunk ID is same, it will update. If it's not, then it will insert. That's what just upsert means. So we just run that and we get success. Now, if we go here, if we go to the data browser here in our index, you should be able to see all our 20 chunks here. So if you remember, our total length of vectors, like a total number of chunks or vectors that we prepared, were in fact 20, and all those 20 are indexed here. And you can see all of them here if you wanted to. So this is done. So we are done with the ingestion step, the entire ingestion step. We are done with it. So the next stage is actually the retrieval stage. So again, would be pretty straightforward. So we have, let's say, some query, let's say what is the VPT model, and we set a top gate 3 to 3 or something like that. So one thing is we'll get the embeddings for the query. So we'll use OpenAI embeddings to again do the same thing. We'll get a query vectors. Yeah, sorry, run the first cell first and then this. And then we'll run the index.query. So it has a function called dot query where we can pass in a query vector. We can say what data do we want back from the results. Do we want vectors? We don't want vectors. We just want the text. So we just set metadata to true and vectors to false. Top case, how many results do we want? So it will be like top 3 similar results. So in this particular case, because you have set the top k to 3. So top case just that. It's like how many results do we want as an output from the query. So you can set it to 5, 10, but this has to be dependent on how much context length you're willing to use for this. So yeah, that would be one thing. So now we would just execute the query. So yeah, so once the query is done, now if we run this cell, we should see the score of our results. So query results will have score ID and a metadata associated with it. So all our chunk ID, the metadata associated with, and how similar it is. So in this, it is 0.77, and then there's 0.76, 70, and so on. So this is our retrieval stage. That's it. This is just a useful thing to actually just print out the metadata and text with the metadata. So it's just to format it. It's just a formatting function. This we get because the point of that formatting function so that we can actually give all of that content, because let's say we have 3 chunks, right, that we retrieved. The top k was 3, so we need to put all of that into our context, right? So we need to format it properly in a text format so that we can send it to the LLM. So it's just for that. Same thing for here. So we just put that retrieve context to answer the queries as follows, and we pass in the context string. So this would look something like this. So this is just for string formatting. So as you can see, retrieve context to answer the queries below, and then we have this document, and then we have some separation with the hyphens, and then we have the next chunk, and then we have some separation here, and then we have the next chunk. So this is so that when we give to the LLM, it knows what are the 3 chunks and all. So it's just the formatting requirement so that LLM understands it better. So that's what we are doing here. And yeah, and this is just whatever we did right now, we just put it into a function together. So this will be key because we'll be passing this function to OpenAI's LLM so that they can actually directly call this function. Not call, but more like give an intention to call it. We'll come to that point in a second. But for now, just think of it like we just wrapped all of this above code that we have, right? Query, building string, and all these. So these 2, 3 cells that we had, so we just wrapped them into a function here called context retrieval. So now we can actually just do context retrieval and pass in a query and get our results. So just context and pass in a text query. Yeah, that's retrieval stage. Any questions here? Sampling, yeah, okay, top case that. Okay, so if everything is clear on that front, we can move on to the retrieval, to the response generation. So now that we have done the retrieval and we have also built out the text that we can pass to the LLM, like text format or string formatting that we have done. Now we need to just write a system prompt and then just give it to the LLM and then get an answer. So let's go to the response generation section. So here, so every LLM in general has something called a system message or system prompt. So this system prompt is basically this initial level set of instructions that you can give your LLM that it needs to adhere to or follow them strictly. Basically, things like it could be a personality that you want to give it to your LLM. It could be a bunch of ground rules, or it could be anything like what to do and what not to do or how to behave. So those basic instructions that you want to give to the LLM and not specific to any user question is what the system message is for. So in this particular scenario, we have written a simple system prompt which says that you are a question answering bot and you're here to answer questions based on the context that was retrieved from a vector index. So this is like we are giving background as well, where that context is coming from, so that it knows, like it has the full picture. And we are also saying that you're prohibited from using prior knowledge and you can only use the context again. Now, obviously this won't be foolproof, but this will at least be to some degree work for us, in the sense that if it doesn't know the answer from the given context, it will just say that I don't know the answer instead of making stuff up, because this is crucial so that there is no hallucination of answers. It's not like generating its own nonsense answers from nothing like we saw initially in the first beginning, right? So it's that same thing. And we are also adding a bit more information, like if you need more information, please ask the user. So if there is any clarifications that the LLM can ask back to the user to give you a better answer, so those things we are adding it here. So this is just our system prompt. And a system message is basically OpenAI has this format of message where you need to have a role. In this case, it could be either system, it could be either user, it could be assistant, or it could be tool. So we'll come to the tool section in a bit, but user is the user message, assistant is what the AI responded with, and system is the one that you are giving this initial set of instructions. And content is basically the text associated with it. Any questions on the system messages? Yeah. Okay. Now slightly. Sure.
So we are using OpenAI right here, so that's
Yeah.
why we use it, the role and content. So
Yeah.
how about like open source models like Gemini or any other?
So any
yeah.
other models, be it Gemini, Claude, or Llama, they all also have this capability now. They also are now compatible with these roles. So they have so like kind of OpenAI has standardized this process right now. So you do the same with other models as well. All the closed source model like Claude, Gemini, all these ones, the API ones, they all support these roles.
Okay, yeah.
Pretty much. Tool may or may not. I think even tool is actually kind of supported with every other model right now, so it's fine, I guess.
So this is like initially we need to set this role and prompting.
Yeah. So even without this, it will work with the default prompt, but that won't do, like, because this is a specific kind of chatbot that we're doing with RAG and stuff. We need to provide instructions. Yeah. Yeah, Darshan, go on.
So embedding model for the query and the chunks need to be identical. However, it can be different from the OpenAI's embedding model. Is that right?
Sorry?
So embedding model for chunk and query has to be same, but it can be different from what OpenAI has used.
Yeah, that's fine. Training. Yeah. But but your both your chunk both your models should be the same. So if you use, let's say, Bedrock's AWS Bedrock's embedding model, then you have to use it both for query as well as index. So anything that you've already indexed with OpenAI, that will only be compatible with OpenAI queries only. Like it both, like the model should be same for both, whatever used for indexing as well as the query, regardless of which model you use. But it has to be consistent. Yeah. Okay. So yeah. So that is that. Now, kind of like a tricky concept. If you have not already played around with OpenAI or not familiar with agents so much, this might be confusing to you, or may not be. It could be depending on how we look at it. But let's come to something called function calling. So now the next stage is so one stage is like if it was just a Q&A problem, okay, we could just we could do the same thing that we did here. We ask a question, we do the retrieval. We already did the retrieval and stuff. Now we take that context and we put it into the LLM with our question, and then we get an answer. This is fine. But do you see a problem with this approach? Anyone? In terms of chatting with it, like if you want to continue the conversation and chat continuously, do you see a problem here? Anyone?
Yes, it is not scalable. So it will not work with the multi-consumer, multi-user scenario. Like users
Okay,
may
so
find
that
user may find answers getting delayed.
yeah, so that is one thing. Scalability, sure, but also and user level. So chalo, let's assume that we are splitting it at a user level. That's fine. Let's say. But
I think also we need to maintain the context, right, for a couple of prompts.
yeah, so that is also one thing. So there are multiple issues with the Q&A single turn approach. So firstly, like the one thing that I was trying to get to that point was key. This, let's say I ask a follow-up question. Okay, now I ask another question. Key, give me more info about Mamba model, let's say. So this was about, so the information. So now what would happen? Now it needs to again go to the retrieval pipeline and make that query, right? To again come up with an answer and stuff that. Now let's say instead of this thing, I ask that, okay, okay, this Jamba seems interesting. Tell me more. So again, either it has to go back to the retrieval and ask a question, or it ideally should reuse the context that's already there. So it should reuse the context that's already there. So by default, if we don't do anything, it would reuse the context that's already there because that's already added to the chat history. But what if it was a different question in the, for example, it was the Mamba thingy. If it was Mamba thingy, then what? So now there comes the concept of tooling or function calling for an LLM. Is that now the LLM would not now we would not directly put this context and retrieval do for it the LLM and then put it into the user. This would be a hassle. And also when you're doing a chatting, right, you would sometimes require retrieval and sometimes you would not require retrieval, right? You won't need to do retrieval every time. You should be able to reuse the existing context that's already there. Otherwise you'll run out of context length. And when you do need retrieval, you also need good retrieval. For example, I asked you, give me more info about Mamba model. Now ideally, what if we were doing it, what we would do, it would just directly do semantic similarity of this question as it is without any changes. But ideally it should actually do like Mamba overview or something. It should search for Mamba overview instead as a search term. Like when you're doing Google search, you don't directly put the question, right? You put the keywords, you put a search phrase. So you should do that, right, to do the retrieval. So yeah, so for example, let's say in the same question I asked, give me more info on Mamba model and also tell me about VPT model. Now these are two different questions embedded into the same query. Now what if we do semantic similarity, we won't get accurate results, right? Because one is talking about something else and some other topic, like two topics in the same query, and semantic results may not be accurate, right? So ideally what it should do, the model is, the LLM should make the query, should make two queries in the retrieval system. It should make a Mamba overview query and it should make a VPT model query. It should ask, get information about these two things from the database separately, independently, as independent actions, and then get those results and then give us an answer. Ideally, this should be what it should do. So in order to enable that, LLMs have, like almost all LLMs right now, most LLMs, support something called function calling, where they can use a bunch of tools at their disposal, make the call, get the response, and then use that response to actually come up with the answer. So for example, yeah, let's take this thing. Let's say I have an LLM here and I have a query here. So now what would happen is, so let's say retrieval search. Okay, let's take a simpler example. Tell me 5 plus 5 into something. So let's say I'm asking the calculation for this. Now, if I directly ask an LLM, it may not give me a direct good answer, right? So let's see if we can. Yeah, so I'm asking the model. So let's see if this is actually correct or not. So I actual answer is this 28450 and this is giving 28092. So obviously this is wrong, right? So the LLM didn't have the answer to it and it hallucinated an answer. So this is what something similar what is happening with our search thing, right? It hallucinates if it doesn't have the answer. So for that, what we could do is, so let's say we wanted to do the same question, we can give LLM an access to something called a calculator. Okay, maybe it has a calculator, maybe it has a integral solver or something like that, or a bunch of other math tools. Okay, some X math tool, right? So it has a bunch of tools here. So now the LLM can actually has been prompted and trained to actually what do is when it has tools available, it won't directly give an answer. It will check if this answer could be solved by one of these tools that it has at its disposal. So in this particular case, it will select the calculator, right? Yeah, maybe yeah, it will select the calculator as its tool of choice, and then give the calculator these inputs. It won't directly give this input directly to the calculator, but rather it would give only the values that it requires to the calculator. It will just give the values, and this calculator will in turn return some answer. So in this case, the answer is once again. So in this case, yeah, the answer is this. Let's say. So this answer it will return, and then LLM will take that answer that okay, calculator gave me this answer, and then it will give you a response like the answer is, and then whatever the answer was. Yeah. So it will basically give this. So this is how a usual agent approach works or function calling works. So this is called function calling or tool calling. So currently it's syntactically called tools, but both are same thing, function calling or tool calling. So now the LLM has available a bunch of tools at its disposal that it can use to give it input. So it's like just how humans use the calculator, right? They don't directly give an answer. They use a calculator, then respond. So similar to that, LLMs can actually access tools. Is this part clear, like what function calling is?
Yeah, function calling is clear, but how it is, synonymous with the agent way of working?
Yeah.
Like,
So now we'll come to retrieval. So now instead of using bunch of math rules, we'll have the retrieval functionality. Do you remember this context retrieval function that we had? So we had a function called, sorry. Yeah, we had a where is it? Oh, sorry, retrieval manner. Yeah. So we had a where is this function? Sorry, I don't know where is. Yeah. So we had a function called context retrieval, right? It says that this function lets you semantically retrieve chunks and stuff, and what this function will do is it will basically take a query, any research query, and give us the direct context output that we can directly put into the LLM, right? So this context retrieval function that we have here is basically a tool here. So this is basically a tool. Now the LLM can choose to use this tool or not depending on the context and the chat conversation. So it's not going to it's not going to do retrieval every time, and it's only going to do retrieval when it's needed. And it's also going to use specific queries. For example, we had the problem that a single question had two different queries to be made, right? So now the model can also do parallel tool calling. So if I yeah, so if I ask this question instead, yeah, so if I ask this question, this can actually call the retrieval tool parallelly. multiple times. With the different context retrieval. So instead of this, it will basically call context retrieval with VPT model as the query.
So the
And
model will do this on its own.
On its own,
We don't
yes.
have to.
Yeah. Yeah. So it will decide what query it should run, how many times it should run, and all of these. So this is parallel function calling that I can do. Sorry. Yeah. So it will call both these parallelly. So it will, yeah. So and then what this will do is whatever this response that we had gotten right here, this big chunk of context that this is the retrieve context, all these three chunks, all that text will be returned back to the LLM. So this LLM will take that back. Yeah. And then it will give us an answer. Some answer, whatever it is. Some ideal answer here. Yeah. So this is what will happen. Now, do you remember there was a role called tool that I was also talking about? Apart from system, user, assistant, there is also a role called tool. So that tool is actually used for this part. This part when the tool give response, right? So all that response will be added to the chat history as a tool response. So this will be that LLMs will be able to understand that okay, it's a tool response, and that tool response is what we really need. So this is how. So we, instead of doing context retrieval manually ourselves, we will outsource that to the LLM to intelligently do the context retrieval instead of blind context retrieval. Instead of directly just taking this query and putting it to the vector database, you would actually ask it to intelligently frame a good search query like what is relevant and only get that information. And if needed, do multiple retrievals for that same question. So that dynamism is basically what function calling allows us to do here. So we are using retrieval as a tool here. Is that clear? Any questions? So I think.
Will we see an example of this? Like, are you showing an example
Yeah.
for this?
Yes, that's what we are going to do in here in the next step. So in the response, do you see there's a mapping that I created here called available functions? So available functions is basically a dictionary of the function name and the function itself. So our context retrieval function itself is here. And we also need to define a schema. So for every tool that we have, we need to define a tool schema in this format. I mean, this is available on the OpenAI website, but it's pretty open-ended, but something usually goes like this. Is like you have a dictionary which has a type called function. So it's only allowed type is function right now. And then under that function, you have keys like name of the function, the description, and the parameters. And the parameters again always going to be object because it will give you a JSON response of the parameters, and that you will have to run and then return the response back to the model. So we'll come to that in a second, but all the different properties. So in our case, we only have one argument, that is search query. We put in like the type of it and the description that the subquery to search for in the document and required or not. Whether because sometimes some arguments in our function may be mandatory arguments while some may be optional, right? So we can mention that here with that. And the description is actually where the magic happens really. So let me just wrap it up. Okay. I'll just show it from here. Yeah. So yeah. Sorry. Yeah. So this is our description of the function. So it just says that this function lets you semantically retrieve relevant data from the given document based on a query. but that's not it. We go into more details, like based on the original query, write a good search query which is more logically sound to retrieve the relevant information. We are saying that it should be able to rewrite the search query according to the context and everything. And also, if there are multiple search query, you are saying that you need to break down the user query and call this function multiple times separately if there are multiple questions being asked in the same question. And we are also telling that this function basically returns you a string of context chunks from the document that you can use to answer the question. So this level of detail we don't normally have in our functions, right? So let's, even in my normal function here that I defined here, context retrieval, I just put this function let you semantic retrieve. This is for a human. But for an AI, we need to give good details, and the more better details we have, not just longer details, but more like good actual make sense thinking detail, logical details that we give on how to operate this tool, the better it would be in the sense. So this is how we define a tool. So this is similar to like if we have any other tool, let's say math tool, algebra, whatever, any other, maybe a Google search API or any Bing API or any other API, internal API you might have. So all those functions also we can define here. So like this, we can just add a comma and add a new tool. So if there are multiple tools, again, the model can decide which tool to activate at a given time. So any questions here? Just run these cells. And now the actual workflow of how this works comes here. So this conversation turn function is our basically our chat function. So we give in a message and a list of messages, that is our previous chat history, and given a list of tools. So our tools is basically this tool schema. Okay. So we are not directly giving access to the function to the model because the code that to run that function will be handled by us only. The model will just give us what arguments to run that function on, like all the inputs to the function it will give. We will run the function for the LLM and then give it back the result. So let's say, so I add my user message as role user to my message history, and then I send the conversation to the OpenAI chat completions API, like model messages. And now these two models, this is two extra. There's tools choice, tools, which is basically our function schema, and then tool choice, which is auto. So auto is default, but you can also specify the exact function name as well if you always wanted to call the function regardless of that, regardless of anything else. That also you can do. You can force it to call a function every time, or you can put it to auto, or you can also toggle it to none if you want. If you for a particular turn you don't want it to call any function, you can choose to put it at none as well. And auto will be the default behavior of automatically deciding. So a response message comes, and then in the response message there will be no message as such, but there will be a tool calls attribute. So each of those tool calls will basically give us like the function name to call, the function to call. We'll actually use our available functions mapping that we had, right? So we had this thing. So that way we can directly get access to the function based on the name. And the arguments, so tool call will give us the arguments as a JSON. So we just need to use JSON.loads to turn that string into a normal dictionary. And then we can actually take that arguments and just function to call and do function args. So let me show you a live running example of it, of how that workflow happens, what all responses we get using the debugger. Yeah. Okay. Let me change the screen. This is good. Yeah. So I have the same notebook as that here. That I'll just add a few breakpoints here. Okay. Okay, so I'm just zooming in. So now, so now what happens is we start with the first step, which is calling the OpenAI API. So this code runs for our given sentence, and actually it is forward. Yeah. So as you can see, we get a response. So this response has different things like choices. So in each choice, we have a message, and inside the message, so message is actually the relevant part to us. So under response message, we will have content, which is none at this case, and function call, which is again different. But we'll have things like role, and then we'll have tool calls. So this is the one actually that's relevant to us. Function call is just deprecated, so it's just not used. But tool calls, and under tool calls, we'll have things like, so because it has access to it has the ability to make parallel calls. It gives us a list of all the tools it needs to call. In this particular scenario, we just have one call to make. So the call that it makes is it makes a call to the function variables name. Yeah, it makes a call to the context retrieval function, and it calls it with this arguments. So it calls it with search query BC via search. So this is the search query that it is sending or asking us to send to the context retrieval function, and it is a string right now. So this is of type string. So that's why once that is done, what we do is we basically split it into all the things like function name, our function arguments is basically now a dictionary, which is a proper dictionary now, key value pair. So that's what we get here. Oh, sorry. Where's this? Yeah. So that is that. And once we get that, we actually call the function. So we call the original function with these arguments. So we go there and we get a function response. So in our case, the function response is this. Yeah. So so this is our function to retrieve context to answer as follows, and all the entire context that it got retrieved is our function response. And now we would actually append to the chat history the tool call ID. So every tool call has an ID as well. So that what we want. So for example, tool call here, it has an ID, right? So so that the model uses this tool call ID to associate the list of responses to each tool call. And also the role we'll set to tool, because there's a response from a role tool, and the name of the function that was called, and the content of the response. So this is what happens. So this is how we do that step of returning back the response to the model as messages. And then we get a new response. Now we get a second response with the same model and message, and with the new appended message. So we are not making any user call, adding any user message in between here. There's just user made a query, asked a question that went to the OpenAI model, and that got returned, and that response is basically that return response we basically appended here, and model will basically give us a second response. So if we look at it, zoom out.
Yeah, Bhavesh, just a time check. How long along?
Yeah, so I'll come to that point. I think we'll have to push the deploy. Can we have a second part 2 tomorrow or something?
No, we do need one workshop next weekend. Bhavesh, we do need one workshop on next weekend for this Dayanand hackathon. Will that work?
Yeah, I think we can continue this part there as well. Yeah, because we haven't gotten to a deployment yet. We are still in the development.
So that's a big part of it, huh?
Yeah. Deployment we might be able to come, because
yeah, I mean we want to do this Dayanand workshop next weekend as well, which we haven't set up yet. So you can continue next weekend. Yeah.
Yeah. So yeah, I'll just complete this deployment part. Yeah. Sorry, development.
One question, one request. If you will take the deployment part next week, can you please help to till what point we need to be ready by next week?
I mean, this notebook, whatever that notebook is there. That's it.
Okay.
I mean, we are actually at the end of the development part. So that's that actually. So let me actually share the other side, the collab notebook.
Also, do you need to install anything or is that?
Yeah, you need to have your AWS account for the next session. Yes. And AWS CLI configured locally on your system if you want, but mostly your AWS account should suffice. Yeah.
Account needed only for the Lambda or EC2 also?
We use only Lambda and S3 and maybe DynamoDB.
Okay, fine.
DynamoDB not that much, but yes, S3 and Lambda will be used. S3 to store the files and Lambda to actually run these functions. Yeah. So yeah, so this is actually that actually. So we just get the final response. So let me just run these here. We just have a message and then I have asked a question. As you can see, it will ask a mention it, call a function and then give a response based on the function's response. So this is how it really works. Yeah, so that's actually that part of the development is actually done. So this is all that we had to do on the development side of things.
So these caller functions might be useful in the scenarios when say you have smart search kind of say
any kind of tool, yes.
So
anything that the LLM.
Like there are few functionalities, use cases where say not every time LLM search will be required. I mean LLM API hit will be required. There might be some metadata or some data available in some database or maybe as a text search.
Yeah.
Don't need to have embedding search. So those kind of, so it will then, are you saying function call will work as a kind of, mix of multiple approaches?
Yeah. So text search is something that you pointed out. Yes. So there is also something called hybrid search where like you use embeddings as well, sometimes text as well. And as for the database, let's say you have a Oracle database or some SQL database or something, and you need to retrieve data from there. So you can have a tool which accepts a SQL query as well, and the model will generate the appropriate SQL query as per your set of schemas and make the call. So it necessarily doesn't have to be search tool only, but it could be any kind of API that you want your model to have access to the external world.
Okay. Yeah, makes sense. Thank you.
Yeah, so we can actually start talking to it actually right now. So let's say I ask, how does Bhavesh explain how the VPT model is used here. So let's say I ask this again. So now I think I already asked it, so it didn't make a call here, as you can see, because it already had it in context. And yeah, actually, let me show you with a simple UI. So a Gradio-based UI that we have. Yeah. So this is basically something like a simple UI to go along with that. So where we can like upload a PDF. So let's say I uploaded a PDF. And it says the PDF files are uploaded, getting indexed in the background. I mean, so this is a sneak peek of what your deployment would look like. Maybe if we are doing it next week, maybe we might have a nicer UI than this as well by next week. But if you go to the vector database, you will be able to see my document here. So the document that I uploaded, it was the same behavioral cloning thing. And as you can see, it's uploaded here, VVI search and all. That same document is there. And now I can ask the same questions like, how does behavioral cloning via search work? Yeah, so as you can see, it's also giving me information that this function was called. Now, if I just take summarize this in 10 words, it will just directly give me an answer. It doesn't make a function call. As you can see, I didn't get a pop-up saying key function call was made, because now that is where function calling is coming in, where it's required and where it's not. Now, if I ask key, how is the VPT model used here exactly? This might make a function call for this question, because the original context might not have this. As you can see, it says VPT model in VC via search. So this is a function call it made to the context retrieval query and give me an answer that encode situations using Impala, CNN, and Columbia. It utilizes this function. So this is how it's gonna look like. It's your own chatbot. You can continue adding more PDFs and archives, and the index will continue growing. But ideally, you can also, you would, like when we go to the deployment section, but we'll also have extra things. We might even have extra things like having the ability to select a few documents based on which you give an answer. And so instead of doing every PDF, we can select all the PDFs that are existing, select a few checkbox and things like that. So there the metadata filtering might come. So this is what we will be ending up with next week as a continuation of the
So
deployment.
Bhavesh, I have one question. So is Upstash is free, or
Yeah,
do we need to pay?
it's free. It's free up to 10,000 requests a day, I think. 20,000 requests a day or 10,000 requests a day.
So how we
Which
can
one, sorry?
our application, like chatbot application?
Sorry.
So how we can integrate?
Yeah, so we are using the Upstash as our vector database, right, for the retrieval here.
Yeah.
Yeah.
So do we need to use any modules, Upstash modules?
Yeah, we just use Upstash, right, in the code. In the notebook code only, it's there.
Okay, fine. Yeah. I'll go through it. Yeah.
Yeah. So here we are doing the Upstash index from environment, and we are doing index.upsert to do insertions and index.query to query it. So it's the official Upstash library itself. No other language or anything, just pure original.
Okay.
Yeah. Anyone else had something? I think someone was saying something. History, it won't contain the history. What does this mean? Yeah, sorry, go on. Someone was saying something. Hello? I think someone spoke, right, just now.
So Bhavesh, I have one more question. So we have also Chroma Vector DB, right? So is this open? Is this open? Like, so do we need to make any charge?
So the Chroma DB is open source. Yes, it will run locally in your thing. But when you want to deploy it, then you'll need to have a server, EC2 server running with Chroma DB, and that will cost us, right? So Upstash is serverless. So we only pay for the actual queries we make. So in this particular case, it's free up to a certain limit, which is quite good. Actually, it's like 20,000 requests a day is enough, I think, for our prototypes.
Okay.
Yeah.
So one request means, so once we give the prompt, that is one request, and generating the response and getting the response is one prompt. So total 2 requests, right, here?
Yeah. So when we do the retrieval, we'll do a query. That will be for the vector database. Yes, only one query, one request. LLM will be the next request. So LLM in this cycle, actually, if we look at our cycle of things here, there are 2 requests being made.
Okay.
1 second. Yeah. So the first request is made when we ask the question, and it gives us a tool choice key. It needs to call this tool. So this tool calls. So that part is the first request to OpenAI. Then we make a call to Upstash, which is one request. And then we make a second request to OpenAI. So 2 OpenAI requests and 1 Upstash request, or the query vector DB request. If at all it requires retrieval. If it doesn't require a retrieval, then it's just 1 OpenAI call. That's it.
Okay.
Yeah.
Can you talk about security? For example, if we have secure documents, we don't want to use Upstash and all those things.
You can use the open source ones, like someone said ChromaDB, right? So there's also VV8 and ChromaDB. So these are open source models that you can self-host on EC2 and stuff. So.
But so Upstash doesn't give any encryption or something, or any such similar.
So currently Upstash is still in beta, I think. So they would have all of that stuff, I think. Like eventually they will have, I think,
Okay, thank you.
at this point. And they are actually just hosting it on AWS itself. So if you have any region restrictions and all, it is done by Upstash. And yeah, I think they would have all that encryption and stuff, I think, because companies do use it. They do have a business enterprise plan. 1 second. If I go to Upstash, yeah. Yeah. So there's a pro version and there's enterprise. So this is the version if you are referring to the security and all that stuff.
The second question, maybe unrelated or tangential. Will you cover fine tuning in some other session and compare this concept with fine tuning and all those things?
So fine tuning is actually not required when you want to just use an external database. You would need fine tuning when you want to change the style of it. Yes, someday we might have a workshop on fine tuning as well, but we will probably not use it for a RAG purpose, like to replace RAG, because the point of a RAG is that it's more efficient. That is one thing. It's more easier to use, because when you do custom models, right, then you have to host models separately. There's extra cost associated with it.
Mhm.
So, but fine tuning would be more suitable for things like, let's say, have an internal knowledge base, which is on around a specific domain. Let's say finance or something, or maybe medical. So there, where there's specific terminology and stuff. So for those things, yeah, I think my voice is echoing. I'm also wondering.
So Darshan, we have a lot of webinars. We have conducted probably a couple of 100 webinars. So we do it every weekend. So fine tuning is covered in lots of other sessions as well. So even tomorrow we have 2 sessions. So almost every weekend we have 3 to 5 sessions on various topics.
Yeah. Thank you. Just the time zones are so different that I can attend only this one. But yeah.
Are you in US, Darshan?
Yeah, Eastern time zone.
Got it. Yeah, we had one this morning, which was 9:30 IST, but that would be, I suppose, 12:30 in New York time. But California folks were attending because 9 p.m. their time. I understand, yeah. We provide recordings as well, so we provide recordings for all the webinars. Bhavesh, are you done?
Yeah, we are done. Yes. So next time we'll actually cover the deployment. So we are done with development. So we can hold on that, I guess. We'll next go to deployment, which we'll use like AWS Lambda for that. And we'll have S3 to store PDF and do the indexing trigger as well. So it will automatically, as soon as it gets uploaded to S3, it will trigger. So the demo I was showing, when I uploaded it, it was automatically indexing it while it got uploaded. Those things, and yeah, and then we'll have a simple front end for it. But we won't like technically cover front end. We'll just have the code there. We can just use it because
Okay, sounds great. So thank you, audience, for joining. Thanks a lot, Bhavesh. Very, very extensive presentation with too many programming details. So thank you. Thank you all for joining. So this webinar is supporting our partnership with the Anand Sagar College of Engineering, Department of AI ML, for their upcoming hackathon on 18th, 19th May. And we do have another session tomorrow at 2 p.m. IST, same support related to the Anand. We have our own Gen AI class tomorrow morning IST. And then Bhavesh will present second part of this next weekend. So thank you all for joining. Thanks a lot, Bhavesh. Very, very excellent presentation.
So how will all get notified? Will there be any LinkedIn message?
So I'm sharing my number. So if you reach out to me on WhatsApp, I can add you to the relevant group based on your interest and expertise. So this is my WhatsApp number, which I have shared. And we have multiple communities. So we can add you if you're not part of the community as well. Just send me a WhatsApp, and based on your profile, we'll add you to the right groups. So you'll hear about all of these sessions.
Meetup also has all the schedule of all the webinars that are upcoming, workshops and everything. So you can keep tabs on that as well. You can sign up for the newsletter and stuff. So yeah.
Yeah. If you RSVP on Meetup, Meetup will send you reminders automatically. So I'll share the Meetup link here so that you all have it, and you can sign up for upcoming webinars so you don't miss them basically. Almost every weekend we have 2 to 5 webinars going on various topics. We also have a very popular Gen AI course being rendered every Sunday morning IST time.
Yeah.
Okay.
So, yeah.
Any other questions, folks?
Yeah, everyone can play around with the Colab notebook and the GitHub repo. If you want, you can also put your hand on deployment if you figure it out. But yeah, we'll directly jump into deployment next week, so we won't go over this thing that we went over today. Yeah.
Thanks a lot. Thank you, Bhavesh.
Thanks.